Okay, in these couple of worksheets that I'm going to have you do, there are various types of problems. Some of them are straightforward. You have numbers on both new shape and old shape. In this case, we have a variable x included. So we're looking for the value of x that will make this relationship, scale drawing, true. So the one thing you always want to do is go with the old or original. And it might be worth it for you to actually label each shape so you remember this. To create your scale factor, all you do is take the new value and place it over the old value. Okay, so in this case, the only two that I know for certain from each shape are 2.5 and 5. So if I take 2.5 and I put it over 5, when I divide, I get 0.5. And that's simply because 2.5 is half the size of 5. So if I know that each side on the new one is half the size of the original one, then I can take a look now at the 5 here, and knowing that this old side has to be double that. Well, if I take 5 and double it, 5 times 2, I get 10. So that means that this x plus 6 must equal 10. So I can set up a simple one-step equation. X plus 6 equals 10. All I have to do is subtract 6, and the value of x is 4. And that's how we solve any of those where they have a variable involved. Now we take a look at a word problem. A rectangle has a width of 4 centimeters, and a similar rectangle has a width of 8 centimeters. So they're just comparing one side to another. So when they start a problem like this, always think the first one that they state is the old. So there's my old. The next one is the new. So what's happening? It's increasing in size, right? What is the scale factor? Take the new and place it over the old, and we get 8 over 4, and 8 divided by 4, of course, is 2. So my scale factor is 2. Okay? We're just doubling it. That's all there is to that. Now we have an example where we have a missing side. There's no x involved, although we could call this x, and then find the value of x that makes this true, right? So if I take a look at the sides that I know, here is my old, and here is my new. So if I place new over old, that equals 16 over 4, and it's pretty clear that 4 goes into 16 4 times. So whatever this value for x is, I need to take that and multiply it by 4 to get 20. Well, what's the opposite of multiplying by 4? Since we have to go backwards from the 20 to the x, we want to divide by 4. So if I simply take 20 and divide it by 4, I end up with 5. So I know my missing piece is equal to 5. Okay, and you can test that again to verify. You can say, okay, my scale factor was 4. That means the new shape is 4 times bigger. So you take that 5 and multiply it by 4, and yes, you get 20. Similar idea. It's an odd-looking shape, but we really don't have to know everything about these shapes. We just need to know that we're looking for a side. And here's the thing. Every single, and I didn't make this clear, every single new shape is similar to the old shape because all of the sides are stretching using that scale factor. So every single new shape is similar. So that's how I know that this side right here is in a proportion to this side right here. Okay, so you're just matching up sides. All right, now we go from new to old. New over old is equal to 3 over 15. Pretty clear that this is shrinking. Now, both of these numbers, and you can type this if it's a proper fraction, you can type it in as a fraction in your calculator to reduce it. But we always want to reduce it. But it's pretty clear that 3 is evenly divisible by 3, and 15 is evenly divisible by 3. You get 1/5. So this is 1/5 the size. So that means I need to take this number 20 and I need to multiply it by 1/5 to get x. Okay, well, that's the same as dividing by 5, and 20 divided by 5 is just 4. You can do that in your calculator. To find the new, all you're doing is multiplying by the scale factor. Scale factor is 1/5, so we multiply by 1/5, we get a value of 4. And finally, I've got one more on another page. I have 2 more on another page, and I don't know if I can separate them. So let's just work on the one. I accidentally got this over top of the other problem. So look at the one that's inside the little box here. A rectangle has an area of 40. If the rectangle is enlarged by a scale factor of 3, what is the new area? Okay, so think about a rectangle and area. So when we think of area of a rectangle, we are thinking length times width, right? So if it originally, that was 40, so that's the old. The new is enlarged by a scale factor of 3. Now, since it's just area, we can literally multiply by 3. But let me show you why. So if you think about the area of the new, if each of the sides, length and width, is increasing by a scale factor of 3, then what I really have is 3L times 3W. Okay? And so that means we have 9W, so technically, 9LW. So technically we're multiplying that 40 by 9, okay, to get the new, instead of 3. So when it comes to area and volume, it's a little bit different. So if we take 40 and multiply it by 9, do that off to the side, 0, 36, 360. Units squared, whatever those units happen to be. Oh boy, I can't spell units. Okay, so it's not being multiplied by 3 when we're talking about the area. It's being multiplied by 3 times 3 because we have to multiply length times width in order to get our volume. So it ends up being multiplied by 9. Okay, area is different than perimeter. Perimeter is straightforward. Perimeter, you use the scale factor, and bam, you've got your new value. Okay, that other problem that's underneath this one had to do with volume, and I'm going to try to make up a volume problem here. So if we take a rectangular prism, essentially a rectangular prism looks like this. It's 3 dimensions, right? That's all we have to think of. So this little box, that's a rectangular prism. Okay, so we take a rectangular prism and let's say that the volume is equal to 24 centimeters cubed. Why cubed? Because now we're talking about 3 dimensions. Well, volume is just taking, of this type of object, is just taking the length times the width times the height. Okay? Now let's say we're going to use a scale factor and keep it fairly simple, of 2. So that means every one of the dimensions, length, width, and height, is going to be multiplied by 2. So if you just set that up where you go 2L times 2W times 2H, and then actually multiply what you're able to multiply. I can't technically multiply length, width, and height, so I leave those as variables, but I can multiply 2 times 2 times 2. And 2 times 2 times 2 is 8 LWH. So that means we're taking 8 and multiplying it by the original volume. And the original volume was 24. So we take 24 times 8. It gets 8 times bigger in volume. 8 times 4, 32. 16, 19. So we end up with 192. Let me write that a little neater. Centimeters cubed for the new rectangular prism. Okay? So anytime you see a volume, you have to multiply those values by 2, right? Or by whatever the scale factor is, sorry. You have to multiply those values by the scale factor. So if this scale factor that is shown right here was 4, it's 4 times L times 4 times W times 4 times H. If it was 1/2, it's 1/2 times 1/2 times and 1/2 times. Okay, and then you just multiply those 3 fractions. Okay, and that's the idea.